love Aiden. He sends me a message. Professor, half that recording was missing. What's wrong? So that little bit will be missing, right? Okay. Guys, here goes. Vertex, out -3/4. I'll put a -1 here for label. Out -3/4 is up 25/8. What is that? 3 1/8. So I need to move up. Mark that as 4, mark that as 3, so reasonable. So out, guys, -3/4, close to a -1, up 3 1/8. Looks like the vertex is going to be right in there. And we'll label this as this. There's my turning point. Okay. X-intercepts. Yeah, we've got a couple of those. 1/2. Mark it over here. I'll put 1/2 right there. Guys, this is so much like the one we did at 4 o'clock, isn't it? You guys were with me? And -2 over here. I think it's a -5. You guys were with me on the other one, I think. So we got -2, -1/2. Y-intercept up 2. Mark it right there. That should be enough to connect. My goodness, that'd be enough to connect. You see that parabola opening down. Let's put something like this. It comes down, sweeps down, picks up that intercept, and there's the graph. Right? No problem. Just a little recap. Now, A and class. The original question was, don't graph. Even though on the quiz Wednesday, I may say do it like this also, graph it. So that's why I did it. Now, if you want to do without graphing, determine the maximum value. We know the maximum value is 25/8. So how can I find that without have gone through all this business? I could easily turn to what? X is equal to, just mark over here for I got it. No, just, can I use -b over 2a? And then make my replacements negative. And guys, in this case, b was, if I go back to the original, which is all covered up here, b was -3. And that's over twice a, and a was at the original -2. Clean that up. I think it's a -3/4. Does that agree with what we had here? So you get the agreement correctly. Now, can anyone tell me how can I get the agreement for 25/8? Just to make sure I'm at the right spot. What can I do to find out, without touching the graph, that 25/8 may work? Yes? I could. Now, if you will plug this in, I know it's a fraction. Awkward. But if you want to go back and plug in -3/4 in these, in the original, crunch it out, you're supposed to get, what was it again, guys? 25/8. Also, you guys who like formulas, you could use that, what? 4ac minus b squared over 4a. I'm just going to plug it in. Let's find f of this. I know it's a fraction, it's going to be a little awkward here. It's -2. Whoops. Oh, you know what? It will be better. Now I'm going to go back to the original. It'd been nice to just plug it here. Because I see a 3/4, so -3/4 plus 3/4, which cancel immediately. If I plug it in here, in the red, you get 25/8. Is that true, guys? Now let's go back to the original, just in case. Okay, -2. -3/4 squared, subtract 3 times, -3/4 plus 2. We'll go back and look at this. Looks good. Here goes. -2, that's 9/16. No problem there, I hope. Positive 9/4 plus 2. First term, do a little canceling there. Let's call that -9/8. I'm doing my work so quickly. 9 over 4, since I eventually need a common denominator, let's get an 8 here. Let's call that 18 over 8. And a 2, let's call that 16 over 8. Since I did see a common denominator being needed. Put all that together on top, numerators, I see 9 plus 16 is 25 over 8. Does that agree with that? So that would be a way to check this. Is that true? Now, I think that's enough to get a good recap, and hopefully you guys get back into where we were. Ah, my goodness. Now, let's do that handout. Do you have a handout? Please tell me, guys, did we do the SMC under construction problem? Yeah. Did we also do like something tossed in the air and all that business? We did those. Those are applications. Now, I know it's a Monday. I know my class. I've been bragging on you guys. I got to get chapter 3 here started pretty soon. But I'm such a nerd that I'm always looking for something challenging. Mr. Park just made copies for us. I took this from a calculus text where they were asked to answer this, and I looked at it and I said, hold on. They use calculus to answer this. I said, hold on. My class could do this non-calculus. My students could set this up using pre-calculus concepts here. I don't have it to you yet. You don't see it yet, but it's taken directly from the calc book. Mr. Park probably maybe recall doing something like this in one of his calc classes, right? Okay. And so I thought maybe you would like to see this and remind me right near the end of class. I'm going to give you a few minutes to look at first and try it on your own, and then give you a few hints, and then you're going to take this home. You're going to finish it up, and I got a few points to give you. Now, with the world the way it is, you said, Professor, give all this stuff you can so I can take it home, and I can go to AI, ChatGPT, I can go here and go there. I don't need my classmates, Professor, I don't need you. Just let AI find it for me. AI may give you, it will probably more than likely, will give you the answer. It may not use the methods I want. So if when you return this to me on Wednesday, we're going to get a few points, and I noticed I didn't mention how many points, just a few. When you return this to me, and you'll say, oh, Professor, I got the answer. Sure you did with AI's help. How did AI suggest you do it? Oh, they went up here and did that, and this, and this, and this. They said, refer to a calc textbook and refer to Professor so-and-so online. I said, oh, really? And finally gave you the answer. No, I got to see methods we've done in this class. You may know the answer, but you got to use the methods we've done here in this classroom to get that answer. Beautiful problem. Beautiful problem. Okay, so I'll get that to you before we leave. Mr. Parker, remind me of this. Guys, here's where we are. I went through and organized myself. I thought, hold on. I'm so excited about chapter 3. Guys, if chapter 3 works out for us the way it should work out for us, I'll get chapter 3 if I get started tonight. Let's see, Monday, Wednesday. I may be near the end of chapter 3 by the time class ends. Ooh, I got quiz on Wednesday though. May slow it down a little bit. Near the end of chapter 3. Chapter 3 is just so smooth. It just moves along. So maybe just a day and a half to do that. But first, Mr. Parker. Guy, can you still record if I?
Yeah.
Okay. I don't want anyone to send me a message about where half of that recording is. Okay. Guys, we're going to head out here something. I know something in chapter 2 that we're going to take a quick look at before we get into chapter 3. Chapter 3 I love. You'll find out when I finally move into it. What it's all about. The guys right at the top should be, I should have given you the section number, Lisa. I thought about you. Is the section number mentioned?
Yep.
Okay, so you know in the homework what that
Yeah.
section is.
Yeah.
Is it section 2.8?
Yep.
And is it all about absolute value?
Yep.
Okay, so that's the conclusion before I jump into chapter 3. So guys, I have on the handout there, Aiden, since you're close by, guy will ask you to read a few things for me as I stand here. But first, do this. It's all about the professor, come on. Those kids across the street at that middle school, they know this. I guarantee if I probably walked across the street and asked a few of the kids out there, you know anything about absolute value? They probably would say first, and they might say, oh, I remember this. And then I may say, well, I see the two straight bars there, what else? Well, I may be able to place a number inside there and get maybe a number -2, and their translation would be, they're asking me to find the absolute value of -2. We know, from across the street to us, what's the answer? Is the absolute value of -2, 2? Why? Now that they may not be able to answer. Can anyone tell me why is absolute value of -2, 2? As you think about a good why, let me do this. Is the absolute value of 2 also 2? Now someone's going to, I see hands going up. Paul, give us a good rationale why that's true.
It's the distance from 0 on like a number.
Do it again.
It's the distance from 0.
He says somewhere he's been taught that absolute value meant distance from 0. Guys, if on a number line, if I went to the left to find -2, is -2 2 spaces to the left of 0? So we're talking about distance here. So distance is 2 spaces. If I want the 2 there to the right of 0, is to the right also 2 spaces. That's why the same answer is absolute value of -2 is 2 spaces. All beautiful. And now absolute value -2 and 2 are the same number. Now, I doubt, this is the letter A, I doubt, who knows if I have been across the street in a while to visit those kids over in the middle school. I doubt they've seen this. Call this letter A with this blue marker. Absolute value X is equal to, here's like a definition. I doubt they've seen this. But here it goes. It's X if this. On the other hand, definition is -X if this. You, in this class, I've done this before, right? Way back the first week I met you. That's the definition of absolute value. Now those kids across the street, maybe you, and maybe me. If they ask me what's the absolute value of 2, I'm gonna say 2. If they say, is that by definition? Look at the definition. Now, can anyone tell me now, Paul, I love what you gave me, which is exactly what I was looking for. But can anyone tell me based on this, let's call it definition, absolute value of 2 is 2 from Paul's definition. Can you tell me what from this piecewise function? Why must I accept absolute value of 2 is 2? If I just look at the definition. And now think about the distance from 0, which I like though. I like that distance from 0. Go for it.
If you put 2 in.
Okay, now keep in mind, piecewise function's got 2 pieces. Which piece should I plug it into to find the absolute value of 2? The blue one or the red one? Is the 2 there greater than or equal to 0? That's the condition. So since that it's 2 is greater than or equal to 0, I'm going to use piece number 1. And piece number 1 says the answer is X itself. So whatever's inside there, the X, that's the answer. It's obvious. It's 2. But if I ask you what's the absolute value of a -2, just gradually move into it to get some sense of what's going on here. You guys have already said, Professor, it's also 2 by Paul's definition. Why is it by this piecewise function? By the absolute value of -2, where x is -2, -2 is the red piece. -2 is less than 0. So I go to it, and it says the answer should be negative of the x. So this should be negative, here it is, and my x inside here originally was -2, which turns into a +2, and that's why absolute value of -2 by definition is 2. Got to decide which of the two pieces does it fit, and then go from there. Now for us, on the college level, I think I graphed this before. Does anyone recall what the absolute value function looks like? I sort of have an idea what to do with it. What's it look like as a shape? Yes?
V-shape,
Lisa? V-shape.
yeah, V-shape.
So you're telling me a V-shaped graph. I think you guys know me by now. I love graphs. Graphs tell you so much. It would save you a lot of work if you had a graph to work with. She's telling me, Professor, if I recall, and you could graph it from the piecewise function. You had a piecewise function on an exam, I think, last time. She said, Professor, go ahead and graph it. It's going to graph it to a V-shaped graph. It might look something like this. And I'll accept that as the graph. That's my V-shaped graph. By the way, is all of that red graph, above the x-axis?
Mm-hmm.
What does that tell me about absolute value?
Always.
It's always positive. The kids across the street would say that. They may not visualize that graph, but they're going to say it's always positive. That's why it's always positive, because the graph is always above the x-axis, or the parent graph. Domain range, you know what the domain is here. Guys, domain's negative infinity through positive infinity, no problem. Range though, how far down does it drop? 0, and it goes up forever. So that tells me, Aiden and I were discussing something in the 4 o'clock session, not about absolute value, about something else though. So that means if you're asked to answer this, I'll just make up one. What can you quickly tell me, based on this graph, of response? Well, it's absolute value of x equals -6, solve for x. What would you say just by the graph?
No solution.
Try again.
No solution.
No solution. He said, wait, Professor, you've already shown me. It's never down here. -6 is down here. My graph is not down here. So this says right quickly, it's based on the graph. No solution. Now if I ask you this, absolute value, finally move into it, let's make it a +6. Now since I gave you a +6, does this red graph, and I know 6 is up here, does it involve 6? Could 6 be involved here this time?
Mm-hmm.
So that says yes, there's an answer. Now when I say 6, Lisa's going to tell me, hang on now, Lisa, hang on, just 1 second. I'm going to say 6 is right here. There's 6. Now, she's telling me, Professor, this time, there's answers. Lisa, tell the class what you think is happening here.
Or it means the graph exists.
Tell me the answers. What's the absolute value of x equals 6? What's x?
Could be -6
X could be -6 or
or 6.
6. Now, why? Look at this. If I go to my graph, graphs tell you all this. If I go to my 6 that I was involved with and do this, how many points of intersection do you see? Are there 2 points of intersection?
Mm-hmm.
That's why I have 2 answers. A 6 and a -6. So she said, wait, Professor, this over here is going to represent 6. And hold on, there's another one over here. -6. So that's why you get 2 answers for absolute value of x equals 6. You get 2 answers. Is that true? But up here, no answers. Because the graph is never below the x-axis. So be very, very careful with that. Very careful. Lisa, go for it.
Yeah, I just have an additional question. What if inside would be imaginary number of the?
No, we're not going to imaginary numbers with these. No. Okay? So far so good, guys? Now, that said, here we go. Jeez. I'm going to set you up and we'll try some problems to get this done. Let me erase this. Now, in general, let's do this. Let's say this is a graph, and I've got an intersection point here, an intersection point here, and let's go back to the 6. This was 6 she gave me. This was -6 she gave me. We got the red absolute value graph, the V-shaped graph. I'm looking at 6, so I just drew 6 up there, right here, and just drew a horizontal line through it. Now notice it passes through my red graph twice. Now, can someone easily answer this for me and be careful what I'm asking? Can anyone tell me on the side here? I hope I'm describing this so you can see what's going on. When is this true? In fact, let me use the right colors. When is this true? I got a red and somewhat of an orange there. Can anyone tell me what would you look at on the graph now if now I ask you to solve an inequality that has an absolute value, and we have to know how to read this. Red, and then I might get a response. This says, when is my red graph below, less than below 6? And I have the 6 drawn with a horizontal line. So translation, when is my red graph, the V-shaped graph, when is it below 6? Now we'll do this for you, then get a response. I'll shade in for you to show you where I think it's below. The red is below 6 here. The red is below 6, less than 6, there. Can anyone tell me when is that happening? Sophia?
From -5 to positive.
Oh, I thought you were gonna have it. You're getting close. So when is this, right here, which
0,
indicates that, when is that happening from left to right?
0 to 5.
Tell me again.
0, 1, 2, 3.
No, something else, easier than that. Go for it. -6 out to 6. You've solved the inequality. It goes from a -6 out to 6. Done. Now, tell me, based on the graph, to jump into this, when is this true? I use my colors here. When is absolute value of x, the red graph, when is it now greater than 6? Now, translated, and I will do this much for you right now. Let me do it in blue. Guys, this piece right here is above. This little red piece here is above. Okay, what describe for me an interval notation? When is this happening? And that would answer this question. That tells me the red graph is above the 6. How should you answer that? Yes.
Negative infinity to -6, parentheses, and then union, parentheses 6 to infinity.
Perfect. Perfect, perfect, perfect. And you've just solved a not quadratic, an absolute value inequality based on a graph. You won't believe how much information a graph gives you. Okay, guys? So that's just a basic V-shaped graph with something else thrown in to see what's going on here. Now, though, what I need, though, with what we just did, is make a general statement. Let's call this part 2. And Aiden, I'm gonna have you to help me out here shortly. Part 2, let's do this. In general. When they say absolute value of x is less than a, that means, Aiden, would you please check your hand out and see, did I write down something that you can quickly write down for what does it mean if you have absolute value of x is less than a, like I had absolute value of x is less than 6. what did it have for the answer?
Hold
I think it's on that handout, somewhere. Is it? I hope so.
on. Solve each inequality, express the solution using interval notation.
Okay, we're gonna solve those, yes, but did I give you a statement somewhere on the
If
handout?
A is positive,
Yeah,
if A is positive, real number, and if U is an algebraic expression, then absolute value U equals A is equivalent to.
okay, hang on now. So you're telling me I used a U on the handout
Yeah,
rather than an X, and I used an equals first.
yeah,
So you're telling me that means what? U is equal to A
yeah,
or,
U is equal to negative A.
beautiful. Guys, that's what we were doing over here with an equals. And he just said that's, in general, that's what that means. Now, can you tell me on the inequalities, what did I have written on the handout for the absolute value of U, rather than X here maybe, less than A? What does that mean?
Is equivalent to negative A less than U.
Okay, that's a U. Less than A. Guys, absolute value of X, or U in this case, less than A, that's like me doing this, and the answer was caught between -6 and a +6. That's what they're saying is gonna happen. You're caught between a negative A and a positive A. That's all it says. And the last statement there is gonna help me,
Absolute value U
okay?
greater than,
Greater than A,
yeah,
what does it mean?
is equivalent to, U is less than negative A,
Okay, U is less than negative A, or,
U is greater than A.
beautiful. Now, that's more in line with this one. Now, since he's giving the rules here, just out of curiosity, can anyone tell me, if I say U, they're using a U in your textbook, so I use a U rather than an X there. Can anyone tell me, if U is less than negative A, can anyone tell me in interval notation, what does that look like if I say everything's less than negative A? What would that look like written in interval notation? Think about a number line. You got a negative number, you're seeing everything to the left of it. How would you write that in interval notation? Go for it. Negative infinity, up to negative A, open. Please tell me, is that what we sort of did here? Is that what we did back here? Now he tells me, don't stop there, Professor. It says an or here. Or U could be greater than A. What does that look like in interval notation? To be greater than A, place A on your number line, shade to the right. Is that A through infinity? Something like we did on this one. Is it true, guys? Now we've got two rules to follow. And we're going to try to work out some of these problems with these two rules. Hayden, I think those are the only two rules I gave you. These two, basically. So guys, if I see a less than with an absolute value, it means this. If I have a greater than with an absolute value, it means this. And then we're going to try to apply this. Okay? Try to make some sense of this. Hayden, would you please tell me, we're not going to work all those on the handout. Would you please tell me what was the first exercise on that handout?
Absolute value,
Okay, absolute value of
3x minus 1.
3x minus 1, hang on. This. Okay,
Equals 2.
equals how much?
2.
2. Guys, this is an equals. So the rule is, if they want me to solve for x, if I use the first rule there, absolute value U is equal to A, so mine sort of looks like in the blue that, it says U is equal to A, that means this means 3x minus 1 is equal to 2. That's what this means. Or 3x minus 1 could be equal to a negative 2. That's what the rule says. Now, what's it all come down to? You know, like rules to follow. Common sense tells you. If they ask me to solve this, I'm gonna cover this up, guys, right here. If they're saying solve this, Ramsey, what must be inside there if this were empty? to get a 2 in the first place to come out? What could you place inside there if it were empty in the bars to get a 2 to come out? Is it 2 or -2? Are those the two choices? To place inside the bars to get a 2 to come out. And that's exactly what we did. We're saying the inside must be either one of these. And then they want you to solve. I'm gonna solve this real quickly. Guys, I think you're not gonna make a mistake here. I think X is 1. Check me out here. X is equal to, help me out, -1/3, is it?
Yep.
And we're done. Finished. Okay, tell me the next exercise. 80.
Absolute value, 2 minus x,
How much?
2 minus x,
2 minus X, okay.
equal to -4.
-4?
Yeah.
Oh, I am good on this handout. Answer? Which of those two rules should I use, or just common sense? What should I say here? Absolute value of that's equal to a -4. I think we tried it somewhere, over in here somewhere. Oh my goodness, I think I tried it way back here. It's impossible. Absolute value is going to never be negative. It's always above the x-axis. The graph shows me that. So if I see a negative there, this is impossible. Therefore, no solution. We got this. No solution on this one. Oh, we're going to have fun with this. Are you guys doing anything special the 6 weeks for winter session? Because I'll be here. You guys want to redo it? Want to redo it 6 weeks? Oh, that's fine. Do the entire course in 6 weeks. We don't want to do that, do we? No. What's the next one? Aiden?
Absolute value,
Okay.
x squared plus x
That's nice. X squared plus X
equal to 12.
equals 12. Now this one's nice. Right here it is. Back up here. Or common sense tells me if I want to get a 12 to come out, which I do, then inside there could be a 12 or a -12. So that tells me immediately that this x squared plus x could be representing 12, or the inside x squared plus x could be representing -12. It's going to be one of those two. And then I'm supposed to solve each one. The absolute value bars, by the way, are gone. Now translate to what it meant. If I solve the first one, guys, let's move the 12 over right quickly. The green marker's much better. This will factor, save me a little time. X plus 4, x minus 3. And help me out, guys. I think you end up with a -4, +3 in the green. If I try the next one, here we go. See if this orange will work out for me. To solve this quadratic, move the 12 over. Make it plus 12. I'll tell you ahead of time, this one will not factor. So if I try the quadratic formula on the orange, I hope you guys can see that orange. X is equal to, by quadratic formula, -1 plus minus square root. Guys, b squared is 1. Subtract 4 times 1 times 12. Look at this mess. All over 2 if I use the quadratic formula correctly, which I think I did. All together, you got -1 plus minus. Guys, underneath there is 1, subtract 48. -47. All over 2. Whew. Now tell me, could I, if they insist, finish this up, even though it's looking strange, could I say something about it? Square root 47, there's no nice answer for square root 47. You can't even break it down. And then you got a negative sign besides that with it. But could I say something if they insist, and maybe we're going to take us into complex type numbers, could I say something here? Could I write as -1 plus minus? Anyone have an idea what I'm looking for?
Sit an I.
The I. Just quickly write as I square root 47, which cannot be simplified, all over 2, and leave it like that. I could do that and be finished with it, done with it. Okay. Aiden, is there anything else on those solving equations or something else
Yeah.
now?
No, there's one more on that.
One more? Okay, what it is?
Absolute value.
Okay.
2x plus 1
3x plus 1.
over 3x plus 4.
Oh, inside here.
Yeah,
3x plus 4?
yeah.
Gotcha, hang on. And what's that equal to?
1.
Oh, okay. This is just basics. I gotta get these basics done here shortly. Okay, guys, that means on the side here, 2x plus 1 inside there. 3x plus 4 could be representing just 1. Or, what he gave me, 2x plus 1 over 3x plus 4 could be representing negative 1. That's all it comes down to. Then we'll quickly solve the first one. I'm gonna cross multiply or multiply through by common denominator. You guys know how to do this. Save me a little bit of time. You're going to end up with 2x plus 1 is equal to 3x plus 4. You guys want to solve it quickly. You guys who are watching, I think it's negative 3. I did it quickly. I guess did I do it quickly? I think it's negative 3. This one over here, it can quickly be written as, be very careful. If I write that negative 1 over 1, clear the fraction out, guys, I'm going to end up with negative 3x minus 4 is equal to 2x plus 1. I'll do that real quickly. Solve for x. If I have no mistake, I'm going to do mine like this. I see a negative 5. I see a 5x. Looks like maybe a negative 1, if I have no mistake. Would be the other answer. Just solving an algebra equation. I'm stepping back and I'm looking at it. Beautiful. Yeah, looks good. Are we okay? Okay. Jeez. We're not into the good part yet. Now, Aiden, are we now into the inequalities of greater than or less than?
Yeah.
Now, that will sort of finish it up on this. Here we go. Guys, hang on, hang on, hang on. Let me erase this. Erase this. Now, we'll leave our rules here to follow best we can. Aiden, tell me what the first one is.
2x, absolute value, 2x plus 5,
2x plus 5,
less than 7.
less than 10?
7.
7. Now guys, this time it's not equals. Less than, here's the rule we gave you. And you gotta know the rules. If it looks like this, mine looks like this. You can quickly rewrite like this. No absolute value bars. So what does that mean mine can quickly be written as by using this rule? It means I can quickly write this as negative 7 less than this, less than 7. I'm using this rule right here. Absolute value bars are gone. Now to solve for x, easily done. We'll subtract 5. Subtract 5 from all three parts. Subtract 5. I'm going to end up with a negative 12. Less than these drop out, 2x. Less than 2. Divide by 2. Do it quickly because it's not that hard. If my arithmetic is correct, there's the answer. And you guys will follow me, watch out for it, don't let me make a mistake. So am I caught between negative 6 and a 1 if we did all that correctly? Did anyone follow me as I did this? Is it true? I did it quickly. Now in interval notation, if I say please express the answer in interval notation, it means this, you're caught between negative 6 and 1. and you're done. But you have to know which rule to follow. Okay. Aiden, tell me what the next one is. Probably more than likely it's gonna be using another rule. What was it?
2 minus 3x.
Okay, what? Did we get
2 minus 3x.
2 minus 3x? And
Greater than or equal to 1.
greater than or equal to
1.
1. Oh, that's nice. There we go. Now, I know what I would do as a student. You'd like to just jump right into it immediately as soon as he gives it to me. And say, Professor, can you just do something right now? You can't. You gotta rewrite this, follow the rules here, then we'll use it. Now, which rule might I apply here? It says, Lisa, help me out. I got 3 rules here.
C.
Number 3, letter C here, right? It looks like this one. If it does, you can quickly rewrite like this. And drop the absolute value bars. It's got 2 parts to it this time. Can anyone suggest to me in the green here, down here, what would, let's say, this part look like? When I say U is less than negative A, U's inside here. Inside, in my case, is 2 minus 3x. I'll help you out here. Less than, where was it? Negative A, in this case, negative 1. And they got it or. Do we agree with that? The other one says, don't leave this one off. Also, I could consider, where am I now? U is greater than A. My U in this case is 2 minus 3x is greater than 1. See if you guys agree. Did I use the rule correctly? Rule number C, or letter C. Absolute value bars are gone. Now, if I can solve it in green, guys, real quickly, it's easily done. Move that 2 over, get a negative 3. Divide by negative 3, remember to reverse your symbol. I did it real quickly, x is less than 1. That says or. This one's easily done too, I think. This is negative 3x is greater than, looks like negative 1, just move the 2 over. Divide by negative 3, reverse my symbol. X is less than, where am I? What did I do here? Yeah, x is greater than, what in the world did I do here? Is this negative 1 here? It is. Reverse my symbol. How did I make a mistake doing all this so quickly? Did you guys ever make a mistake? Hey, did you copy that down correctly? Is this copied down correctly on the board?
I think you have to.
Is it this?
Yeah.
Okay, and we split it up into 2 parts. We said this part, and I know it's supposed to be equals there with this. That would be 2 minus 3x is, where is it? Less than negative A. And A was, in this case, of course, right here it is. A was, in my case, 1. So it's negative 1. Or 2 minus 3x, down here, is greater than 1, or equal to it. Is that correct?
When you divide negative 3, I think you have to.
Right down here.
Switch the sign.
Is that true? Symbol reverses? Now, will the symbol also reverse on this one? Now, divide by negative 3 is going to be what? Less than? Is that 1/3? Very quickly, the symbol did reverse. Jeez. Are we okay now? Yeah, quickly. Applied the rule, and got the answers. Can someone in class tell me, in interval notation, if all that's correct, x is greater than 1 looks like what? Written in interval notation. Sophia, what does that look like? X is greater than 1.
It's, oh, interval.
Yeah, interval
Oh,
notation.
sorry. That's gonna be, 1, infinity.
Beautiful. Or, now can you help us out? Be careful now. When I say x is less than 1/3, what would that look like in interval notation?
Oh, that's gonna be, negative infinity.
Beautiful.
And then 1.
1/3. Beautiful. And there's your answer. Whew. Aiden, before I turn back to you. Guys, you have to know, I've got 3 rules here to follow. You have to know, is it one of these basic ones, professors, solving the equation, those are the easier ones? Or is it one of these with the less than or greater than, where you have these 2 rules to follow, and those 2 rules came from, I had a sketch over here that I erased. In my discussion over there, that's where those rules came from. And you have to know which rule to use to solve the absolute value. Aiden, are we almost finished with all that? Or is there something else?
No, there's more.
Is there one more?
Yeah.
Just one more?
No, there's a
Hang on. Let me put it at the top here. I'm gonna need this to what it says.
-3,
-3,
absolute value,
okay,
4x plus 6,
4x plus 6,
yeah. Greater than -27,
-27.
yeah.
He tells me when we stop after this one.
No, there's 3 more.
Whoa, we're not gonna work all 3. Jeez. I'm gonna do just enough to give you guys an idea of what to do. Now, the reason I have to place this on the handout is, wait, Professor, let me jump over there to those 3 rules and see which rule would I have to use. Lisa, I would think the way you give it to me, I see a greater than symbol. So if I go over and find,
It looks like we.
that looks like it's letter C
Yeah.
or choice 3. But this one's a little tricky.
There's no equal sign,
Give me again.
no equal sign.
There's no equal sign, that's okay though, that's okay, but can I still not use letter C? There's something going on in this one, that's why I placed it on the handout, that I cannot use letter C, and you gotta watch out for it. I see a hand in the back there. Yeah, exactly, he said, hold on, Professor. This one that Aiden just gave you can be simplified first. Divide both sides by -3. These will cancel. So you got an absolute value of 4x plus 6 less than 9. Are you kidding? The symbol reversed on me. Which means now I'm not into choice C, I'm into choice what?
B.
B. In other words, I gotta use this business to solve the answer, which I love. This is one of the easier ones. Guys, can anyone tell me, based on choice B, what would this look like expressing this? See a hand going up. Yes?
-9 less than 4x plus 6 less than 9.
Love it. The guy's on it. That's exactly what it means. And by the way, are the absolute value bars now gone? Now I can solve it. I can solve it from just basic algebra. Guys, to solve this one, I'm going to solve for x. Add 6, all 3 parts. -3, less than 4x, less than 15. Don't let me make a mistake. Divide by 4. And if there is no mistake, I'm going to end up with some strange numbers, but it looks like that.
Why is it not positive 6?
Which one now?
In the middle?
Where are you talking about?
It's plus 6.
Was it plus 6 here?
Yeah.
Man, jeez. Hey, why didn't you tell me earlier?
That would be -15.
No, we're not finished yet. Yeah, he says I copied down wrong first. Now it's 4x is equal to what? Is that -15?
Yeah.
There you go.
And
And what's 3?
3 over 4.
And 3 here. And we're going to end up with up here, -15. 3. Jeez. -15 over 4, and what was that, 3 over 4? Jeez. Now it's okay. What's that adjustment? Answer in interval notation, you're caught between, the x is caught between. So you go right like this, you're caught between these 2. Done. Gee. Now tell me, is that enough there with all that going on, with all the sign changes and negatives and positives? Are we okay at this? So when you finally have a quiz on this, which will not be this Wednesday,
Next Wednesday.
you have to know which rule to follow, how to set it up, and then how to express the final answer using interval notation. Aiden, you said there were some more examples.
Yeah.
Is there anything else on absolute value after those other examples, or does it jump into another section,
Jumps into another section.
like 3.1?
No, it doesn't jump into another section, it's part of the same part.
Same part of the same thing. What's it say down at the end of the handout?
Zeros of a polynomial function.
Oh, that's chapter 3. That's where I want to be. So you tell me if I should work the remaining 3, that's all I have on that handout concerning absolute value, 2.8.
Right, yeah.
I'm just wondering if I've done enough for my class to describe absolute value. It came down to these 3 rules here, how to apply, which rule applies, and do the work, write the answer in interval notation. I think with all we've done, I think my class could do the remaining 3. I don't know how scary. Tim, read the last one.
The last one, absolute value x squared plus 2x less than 15.
Hang on. X squared plus 2x is less than how much?
15.
Let me just set this up for you real quickly. Now, which of the 3 rules are you going to use? Lisa, you're good at this, less than. She says, Professor, quickly write that like this. So that means this, from her choice, will quickly be written as, here we go, negative 15.
Less than x squared plus 2x.
Beautiful, hang on.
Less than 15.
Now guys, I'm not gonna do it completely. There's partial credit. That's what it looks like. The absolute value margin.
Oh, do we have to take the square root?
Now, not necessarily a square root, but before we take the break, does anyone see a quick way to do this one? The reason I asked for a quick way,
I know.
back here, a student says, Professor, when I had this one, we went from here to here. This one was easily solved. Oh, it was easily solved.
Complete the square?
Might be a completion of square involved, but is that one as easily done as this one? No. What's wrong with this one? It has an x squared in it. And Lisa's all getting excited. She says, oh, x squared, square root. X squared, completion of the square. X squared, quadratic formula. X squared, something. Okay, I'm gonna do this for you and stop. And let you guys, maybe this should be an extra credit later on. Can anyone tell me, you can't solve it as easily as that one over there, I wish you could. Can you tell me someone, at least, what does this look like? Split up. I've got to combine into one inequality. Can someone tell me what it looks like if I had to split it up? Because that's actually 2 in 1 here. Yes.
Negative 15 less than x squared plus 2x.
Beautiful. And what's the other one?
X squared plus 2x is less than 15.
There they are separated. Now, I see it's time for a break. Time for me a break too. Here we go. This one, I'll do this one first. You just have to move 15 over and get this. We'll do that one first. Would you now do what in the attempt to finish it up? Factor it, thank you. The green one will factor into x plus 5 times what? X subtract 3, I think. Whew. Oh, boy. Oh, boy, this could be a nice little extra credit, but you're math two, you're pre-calc. You're not math one. Can anyone tell me at this point before we take a break, I'm not gonna actually do it for you, what someone, this clever class, would you do to at least get this one now solved and answered, and then go back and worry about this one? Do it again.
Is it sign analysis?
Sign analysis. You have to get your critical numbers, place them on a number line, and test, and find the answer by using sign analysis on that. Lisa, which I'm not gonna do for you, this one is tougher. I'm gonna give you a 10-minute breaks to you guys, just a second. Can anyone tell me what might you do on the first one, which is the tougher one? What might you attempt to do, though, in an attempt to see what's happening over there on this one? This one. What can I do? What can I do? Just sit there and say, Professor, I'll see you in the winter session. No, you're not going to see me during the winter session. Yes.
Do you place the minus 15 on the right side?
Okay, you want me to move that 15 to the right? You got this. If I moved it correctly, I'm doing everything quick tonight. Is it plus 15? And I'll tell you ahead of time, it will not factor. Try to solve it now. If it will not factor, where are you going to turn to? Quadratic formula, and I can tell you right now before I take a break, if you apply quadratic formula, I think you get imaginary numbers.
Does it mean there is no solution?
Oh. It might mean, that's why I brought that in on the handout. It might mean that, but right now it looks like imaginaries will come out, and maybe you say, Professor, maybe I can't deal with that at all, it's imaginary. I can just accept the other one that worked out nicely if I do side analysis. It's a mess. Was that the last one on the handout?
No.
It's not.
Oh, that's the last one, but there's two other ones we didn't do.
Okay. This is the one, ooh, I'm glad that you mentioned this one too. Oh my goodness. I'm gonna leave this on the board. I'm already said everything else while you guys are on break. And finish this one up. I gotta finish this one up. Then I gotta move into chapter 3. My goodness, I gotta get into chapter 3. Oh. Okay, we got a 10-minute break.